whether or not the email has been created already. So if I try to create a an account with this email, it says this account already exists. Please log in. So I'll log into that account. And here we have a page that just shows all of the show listings that have already been created. I have just like uh, some crap data in here, so don't mind the names and whatnot. But this is where all of the shows will populate, and these routes are protected, of course, based on the session user. So each listing here is shown with some conditionals based on whether or not the event was posted by the current user in session. If it was, it shows edit, delete, and guest list. If it doesn't, or if it wasn't posted by that user, it will at first show an RSVP button here. So I'll create a show real quick, just with some random data in there. 7's my number, so we always put 7's in. I guess I'll go over the create a show while I do. These are all validated text inputs. So they all require a certain amount of characters or a certain format. You can add a show name, show date, venue, address, a ticket price, and then you can also add a payment link to your PayPal, your Venmo, or whatever you want to use to receive payments for your tickets. Because a lot of the times that's how we as artists are selling tickets these days. It's like, hey, I'm putting on a show at this venue. Tickets are $10. Just shoot me a Venmo for $10 and I'll put you on the guest list. So we create a show, and it looks like I guess if it was one of these two here. But if I log out and just log into a different account, we'll be able to see how that populates. So it would be this show here, and we have get a ticket because this user has not yet RSVP'd to this event. So we can click get a ticket, and that'll take us to the show details, where we have all of the information about the show and then a little bit of information on how to get a ticket. So if I wanted to come to this show as a fan, I'd click the link and it would take me to the payment link associated with that show that the artist chose. And then once I send my door fees, I just click RSVP, and that'll direct me back to the main shows page. Now that RSVP button only shows or has some conditional statements built in, where if the user is already RSVP'd, it will let them know, and then they're not allowed to RSVP again. And also, if they try to RSVP via the URL, it'll also protect that route and just make sure that we don't get duplicate users on our RSVP list. And so then we can go back to all shows, and there's also some conditional statements here on these show listings where if you've RSVP'd already, it'll say your ticket is still being confirmed. Check back later. So then we'll go back to the artist of that show or the listing user, and when they open it up, they can click on the guest list, and that'll take them to a route that's only accessible by the listing user, where they can see a guest list of all of the users that have RSVP'd, but the payment has not been confirmed yet. So as the artist, I would go or I would see this page and I'd say, oh, okay, G8 wants to come to my show. They said that they sent their door fees. I'm going to go check my PayPal and make sure that I got that payment. And if I did, I would confirm the guest, and it'll populate them in the confirmed payment category of that page. The way that I set this up is actually by using, well, it was something that I learned how to do while I was creating this page, and also something that I found a sort of a limitation of my skill set with. This is set up by using two many-to-many relationships, one of which is for the not confirmed guest list table, and then a second many-to-many relationship for the confirmed guest list table. And one thing that I was trying to do while I was building this app was create some foreign keys on one many-to-many relationship so that I could have an extra value there that would say true or false. Has this user paid their door fees yet or not? And I had some trouble just figuring out the right ways to access that data once I set it up. So this ended up being sort of the most efficient way for me to make this feature work. There's a little bit of math logic down here at the bottom that will just check the amount of entries in the confirmed guest list, and then just do some multiplication based on ticket price for that show, and show us how much revenue we have so far. Another fun thing that I added that I really liked was once that ticket has been confirmed by the listing user or the artist, the user that RSVP'd to that show will see this conditional change, and it'll say your ticket has been confirmed. See you at the show. So they get a little feedback about what's happening on the artist side of things. You know, they can just see if their ticket's been confirmed, all that kind of stuff. And one thing that I'd like to add in the future is maybe like some API integration so that the fan who RSVP'd to the event is able to like get an email that says, hey, your RSVP is confirmed, or maybe send them like a pre-built like graphic with their name on it that says, here's your ticket, show it at the show. And then of course I would love to add like, sending and receiving payments through through APIs on this website eventually. But other than that, just basic create, read, update, delete. There's an edit page for each event where the original data from that show will populate, and it has all of the same validations that the create does, requiring ticket price and all of these fields really. And then, of course, all of the routes associated with deleting and viewing certain information is protected. So users that didn't post the show can't go in and modify RSVPs, confirmations, delete those listings, any of those things really. So that's kind of where the functionality of the website is at right now, and the features that I've been able to implement so far. Yeah, I'd love to field any questions about code or how I did, or how I added any of this functionality so far.
This looks awesome.
Thank you so much,
really
man.
Cool. Yeah.
Thank you.
When you were saying that you wanted to integrate like an actual payment, Stripe is typically kind of the most popular for that. So they're,
yep.
Because they're the most popular, they have good integration, they have good API stuff and documentation.
For sure.
So yeah, so maybe
For
check
sure.
into Stripe. This is awesome.
Definitely.
Again,
I looked at a little bit into like PayPal integration as well.
Yeah.
But there was a lot of like, applying for accounts and things like that.
Sure.
So I figured for this thing, maybe hold off, but definitely something I'd love to add here shortly. Yeah.
Yeah, that's awesome.
Cool, man.
Really cool.
Any other questions from anybody else?
Question, because I DJ and I make music too. I'm a drummer and a bass player.
Cool,
But
man. Cool.
these
Yeah.
days, as a DJ, or because we don't really manage, but as a DJ, you lose money a lot. Because I have the same idea on the project, and I was wondering because you said you had the math logic. If there's a way to do the kind of the digital property method, where I was thinking where if we could tie it to a user ID, they would get 10% of whoever referred them. So they wouldn't even have to ask or book a gig.
Mm,
So like a lot of
yeah,
times
yeah, yeah.
I might book a friend on a gig, and he may get 3 or 4 gigs from that because I gave it to him. And I may never see $1 of it. But if he signed up through the app, every time that they either booked
Mm,
a gig because they got through my ID, I would get
yeah.
10% of whatever they booked it for. And they never even had to ask or touch or whatever. It was just automatic to me. But
I
I
think
couldn't figure out how to do the logic.
I think that that could be something that I could implement if I added a field in account creation that was, I guess it could just be like a Boolean field really, but like, are you an artist or not? If it's not an artist, of course, it's a fan. But like, for example, if I, as an artist, referred you to the to the platform, then I could receive a percentage of the ticket sales that you sell on there, or that could apply for fans too. Like if
Correct.
a if a if a fan, well, I guess in registration you would have to add both the artist or user field as well as a field that would allow you to list an email of a referring user, either artist or fan, and then that would just be another many to many table connecting uh, a user to a user, which I actually saw some information about uh, creating tables that reference uh, the same data table. So it would be like a many to many relationship from one table to the same table, essentially. Um, I I believe that's uh, how you would link that data, and then of course there's a long you'd have to walk that idea down the road into how you would actually implement it into you know uh, like saving the total revenue of a show, or like all of the tickets purchased by a user who had been referred by another user, if that makes sense.
It
But
does.
it's almost hard to even think out without starting to write things down, so you don't lose track of where
Yeah,
you're at in the order of operations, if you will.
for sure.
Yeah,
Yeah.
but I love
Well,
that
great.
idea, man. I think that would be a cool feature to add in here, in a way to sort of like uh, it would be a cool buy-in for
Yeah.
artists and users to say, oh, like maybe I could, if I refer a bunch of users to this, I might get a bunch of like in-store credit that allows me to buy tickets to shows I want to go to, you know?
Bingo.
Sure. Yeah.
Yeah, that'd be super sick.
Yeah. Well, great. That's awesome.
Mhm.
Thanks for sharing this. Yeah, sounds like you got quite a bit of work of things you could do. So,
Definitely,
so
definitely. Thanks for having
awesome.
me, man. I
Yeah,
appreciate
of
it.
course. No, happy to watch it. That's awesome.
Cool,
Cool. I'm
brother.
gonna snag the share screen and we'll get started with class today.
Great.
Awesome. We are already recording. So, friends, it is week 3, day 3, which is wild. That means we, friends, have one more week until you guys are done. Really, you have this next week. Don't forget that next Monday is a holiday, so you guys should be taking some time, maybe not all day if you got a group project, but taking some time for yourselves to just rest a little bit. Go do something fun. That is your core assignment. Not really. I can't legally do that, but go do something that is good for your soul on Monday. Tuesday, Wednesday, normal classes, and Thursday just as normal, but we'll have group presentations. Just as a little bit of a like heads up, Friday, normally it is Sunday of every stack or of every week when everything's due, right? Which by the way, this week you've got 4 core assignments. So please make sure you submit your solo project. Your group just has to send me 1 email, but each of you need to submit a group project proposal. It can be the same group project proposal, just like copy paste. That's fine. But you each individually have to submit it. So even if somebody sent it to me, don't think that because it's attached to your account, so just make sure you guys all send it. We have fronts and display, which are core assignments for singly linked lists. And then you've got your group project. That's it. So after you do display, you're officially done with like actual homework, and all you have is your group project, and then you are done. That said, everything is due at noon. So I'm going to say due at 12 p.m. Oh my gosh. 12 p.m. EST. Everything is due at 12 noon PST on Friday. So it is not Sunday for next week. That includes your group project. We do have group project presentations. I'll be setting up something similar to this. And we will kind of have, there's not that many groups. But I might be setting up, I might be setting up, we might be doing group project presentations on Wednesday too, because I actually think there's quite a few groups. There's 13. Yeah, we'll probably need 2 days. So I'll set this up, but I'll put group projects. I'll put up a list that you guys can do similar to this. I'll honestly just copy this and then we'll go from there. But it is still due Friday. So even if you don't present it, your group project is due on Friday at noon PST. That is a non-negotiable. There's nothing I can do. I cannot push it further than that. I know it says final day to submit assignments in group. That's to present. Noon Friday is like the absolute cutoff. So if anybody comes to me and says, hey, Will, I had a hard week, can you extend it? I cannot. I literally cannot. So noon Friday. Hopefully everybody can do that. Cool. You do still have discussion questions this week and next week. Now, again, I put final day to submit discussion questions. This is honestly, I'm bluffing. Noon Friday is for everything. So make sure you do everything noon Friday. Same thing with assignments and group project. But try to get your group project done because then A, you're done, right, with the whole course. And then B, you can present and that makes it a lot more optimal. If you cannot get a hold of anybody in your group, please send me an email because I cannot legally put you guys in like a group. I was going to send out emails to everybody like, here's your group. I can't do that. Because it's considered personal information, and so I can't do that. But if they're not on Discord, you need to let me know immediately, and then I can email them and tell them to get on Discord and get in contact with you. So if that's the case, please let me know. Tonight we are talking about recursion, and this might look dumb at the beginning, but it's actually planned in place for what we're doing with recursion. This is just a representation of how recursion is. So let's go to, I'm going to turn off my good old Copilot. And let's talk about recursion. What is it? Well, recursion is a way that we can set up an algorithm that allows us to basically have a function call itself. And there's many reasons why we would do this. When we're sorting, that's going to be a big thing. When we're dealing with like searches, that can be a big thing. There's one called merge sort. We're not going to get to it today. We'll do it next week. But that uses recursion, and it's a way that we can break up problems into smaller pieces to kind of make it more optimal. But from a high level, what it is when a function just calls itself within itself. So Recursion is when a function calls itself within itself. You gotta ask yourself, what the heck do I mean? Well, let's pretend that I wanted to count down. So I wanted to make a function. Oop. Sorry, I used one of my little keys there. Make a function, one of my little F keys, that counts down from a number recursively. Now you might take this and say, okay, if I were to tell you, hey, write a function that takes in a number and then count down to 0 from that number, what you would likely do is just do a for loop, right? Where you take in the number that's your starting place and you decrement. That's fine. But let's say we want to do it recursively. It's less code. And it is just a way that we can practice this. So what that means is, let's say we wanted to make this function. So we're going to call it function countdown. That's going to take in some sort of number, right? Cool. Now, really, what we're wanting it to do is we're wanting it to console.log the number, because I want to just kind of print or console log, the first one and the next one and the next one and the next one. And if you think about, we're breaking down our for loop, all we're doing is decrementing, right, from that number. So I'm going to say like num minus minus, right? I don't need that, but I can. Well, if we're thinking about this, if I were to say count down num, what's happening here? Sorry, I got something stuck in my throat. What would be happening right now? Let's kind of T-diagram this. And move to annotate, it bugs me. Okay. Sorry, my annotate screen wasn't there. Let's say we started and num was equal to 6, right? Num was 6. Well, right here, I'm console logging num. So I'm console log 6. And then I am decrementing by 1. So it's no longer 6, it's 5. And then I am calling countdown num. Now, this is introducing a new idea called a stack. It's called a call stack, right? And you might have heard this when we did web fundamentals, maybe, probably not. It's a little bit more of an advanced thing. But let's think about what happens whenever I say, if I were to say X equals, count down. Let's pretend this wasn't recursive. Countdown of, 6. What is happening in my code? If it's, if I say Y equals 3, and then it gets to here, what's it going to do? Anybody tell
So
me?
negative or repeat?
Well, if it just from like a basic stem, forget about this guy. Let's just say that we had a for loop that created an array that went from 6 to 0. What is going to happen? So remember, JavaScript reads from top to bottom. So it's going to come here. It's going to create Y as 3, right? Then it gets to X. But before it can give a value for X, what's it got to do? Is this a default value from X, or do we have to do something?
You have to count down or iterate.
Yeah, right. I've got to run the function, right? And whatever the function gives me back, that's what X becomes. So let's say that it was, maybe the function just goes from 6, 5, 4, blah, 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 right? When we get to here, we see this function and this goes onto our stack, right? And so it says, okay, great. Before I can assign this value, I've got this countdown of 6, right? And then once it is fully complete with that, then it can go and assign a value to X, right? And so what I really want to point out here is we have to wait for the function to be complete before it can move on to the next step, right?
So it'd be
So when we're dealing, go ahead. Was there a
X would,
question?
X would be 0, right?
Yeah, if we're, well, for right now, we're starting with 6. It just depends on whatever countdown did. Right now, technically, we have an infinite loop within our function. But more so, I just wanted to point out, before we can assign anything to X, we have to go and run this function to see what it gives us back. Once that's fully complete and done, then it can assign X to some value.
Okay.
Cool. So here, what's happening is on my stack, right? Let's say in this case, we said X equals count down. I know there's capital D, but it's fine. 6. Well, on my stack, I now have CD. I'm going to say CD 6, right? And once this is completely done running, then I can give and go and give a value to X. But in this, what's it have me do? It has me console log the number, so in this case 6. I'm decrementing, so now num is no longer 6, but it's now 5. And then I am calling this function. Now, remember, I cannot have, this cannot be complete until the whole thing is done running, right? But now I have a new stack call. So now I have CD of num is no longer 6, but it's 5, right? So then what do? I console log the num, which is now 5, because we go in and now we have to run this next function. And I say 5. I decrement, it's no longer 5, it's 4. Is this done? No, because I called a new function. We go CD of 4. Same thing. I console log, I enter in, right? I'm just continuing to run this. I console log 4, I decrement, now it's 3. We're just going to go to 0. Oh, I call this function. So now on my stack, I go CD of 3. Right? 6 is not complete yet because 5 needs to be complete in order for 6 to be complete, but it can't be because it keeps calling another function, right? And this hasn't been finished. So we go console log 3, we decrement, this is now 2, CD 2. We console log 2, decrement, go to 1, CD 1, right? This is all my stack. We go 1, we decrement to 0, and then maybe we say CD 0, not maybe, we would. And let's pretend that we have some sort of case in here to say if num is less than or equal to 0, then maybe I want to console.log num just to make sure we get it, and I want to return. What happens when I return a function?
You end it.
I end it, right? And whatever called that gets that value, right? Or gets a value. Now, in this case, we don't need a value from this return, but exactly, Austin, we are ending the function call. So now, let's pretend we have this built in. We get to 0. Num is now 0. We call CD of 0, and it's going to say, hey, is num less than or equal to 0? It is, right? So then we enter into this and we console log 0. And then we return, meaning that we are done running this function. And so we can take this off my stack. And then it comes back. Remember, 1 called console log 0 when we were in 1, called it right here, right? And so now that that's done running and we got a return, now 1 is done running, which means 2 is done running, which then means 3 is done running, which means 4 is done running, which means 5 is done running, which means 6 is now done running. And if we were to, right now we just console logged, we didn't do anything with it, but you know, really X would become undefined because we didn't return anything. We just said return, but hypothetically, you know, if we wanted to return something now we can finally assign X because we went through our entire stack. Does that make sense? It's just calling within itself. And remember, a function cannot finish if another function until a function call within it is done running, right? I'm going to pause there. Let's think about it. We'll kind of walk through it. Again, in this case, let's T-diagram. We have this countdown function. And let's say we call it. And we say, I'm going to do just 3. So we say count down of 3. Perfect. So what's going to happen is we have this num, right? Num is now equal to 3. Cool. And then it's going to check, is num less than or equal to 0? It's not, so it does not enter here. And it goes and it console logs 3. Right? Num is num minus minus. So now num is no longer 3, but it's 2. And we say countdown num. So I'm now calling countdown of num, which is 2. And this one right here is the first one on my stack, right? It's not done running because I have a function call. And this function is not done running yet. Because then we go 2 and it says is 2 less than or equal to 0? It's not, so we don't enter into there. We console log the number. We decrement. It's 1. We call countdown 1. Okay. It goes, is 1 less than or equal to 0? It's not, so we console log 1. We decrement, so now it is 0. We call countdown of 0. It says, is num less than or equal to 0? It is, so we go in and we console log it. And then we return. When we return, the function is done running. And remember, with 1, its last line on 1 was CD. I'm just going to say CD of 0, right? Because num was 0 at that case. And that's when we had it as CD 0. And once this returns, well, this is done running, right? And then we get to the end of my function because this call. So then we can take off CD 0. And then that was the last line was CD 0. So then that means this one's done running. The last line of CD2 was CD1. So that means this one's done running. And then it's kind of a cascading effect. And then we go, and now this one's done running. And then finally, our function is done running. So when we are dealing with recursion, it is when a function calls itself within the function call. Because then you were just continuously, it's called recursion, to where you're just continuously calling yourself until some condition. You must have a condition that ends it, or else you're going to go into what they call Stack Overflow. Now, you guys have probably heard of Stack Overflow as a website that was wildly popular, honestly, until ChatGPT came down. But if we've got an infinite recursion call, let's say we didn't put this condition in here, you know, num can be an infinite number, we would get to something they call Stack Overflow, meaning that we've added too many things to our stack. And remember, because it's calling CD3, which is calling CD2, which is CD1, CD0. And if we didn't have this condition here, we'd go to -1, -2, all the way to negative infinity, right? And then our computer would slow down, crash, or break. And that's what they call Stack Overflow. We've added too many things to my stack and it can't keep track of it. We gotta, you know, we can't have that much. I'm going to pause there. Are there any questions on recursion and how it works. We're gonna do another example to maybe see why it might be optimal. Because right now you're probably like, why the heck would I do this versus doing a for loop? The
I was
reason
just about
is-
to ask that question. So
Yeah.
yeah, that would be great.
Yeah, so the reason is because it's actually more optimal. Here's why. We're gonna get to something called merge sort. And merge sort, I'm just kind of giving you guys a peek into the future, so that way you're not like, oh my gosh, I'm just gonna tune out because this is dumb. What merge sort does is, let's say we have an array of 1, 5, 7, 3, 2, 10, 19. And what I want to do is I want to put these in order. I want to sort them, right? If you just use the dot sort in Python or JavaScript, it uses something called time sort, which actually isn't as optimal as merge sort. But what merge sort will do is it will say, okay, well, how many values are in this array, right? And it's dynamic, right? The array can change. So let's say we have 1, 2, 3, 4, 5, 6, 7. We're going to go 8 just for ease of use. We're going to say 8. What merge sort will do is it's going to break things up into little pieces, and it's going to find a middle. It's going to cut it in half, and it's going to treat this as my left and my right. Then what it's going to do, it's just going to break my left in half, and it's going to treat this as my left and my right. And then it's going to do that for both sides, and this is my right, left, and my right, right. And then it's going to break this up, and it's going to keep breaking it up in half, right? It's going to keep having it. And then once we get to here, we're going to say, okay, well, let's look at which one is bigger, and then we'll just start moving things. Now, visually, that might not make sense, but let's think about it from like a mathematical perspective. Let's say my array has 8 values in here, right? It's got 8, right? This has a len of 8. Well, if I double the size of that, right? And now I have 16 values. If I had an O of n, meaning that I'm going through each one, how many values, what does n represent here?
Number.
Yeah, the number 16, right? And this is 2x the size of 8, right? So I have to do 8 more operations if my array is double the size. If it's triple the size, I have to do 3x the amount of operations, and so on and so forth. But in using something like merge sort, how many more operations would I have to have if I doubled the size of my array?
From 18 to 16 is 2.
Let's think about it. If I had 8, so I'll just say 1, 1, 1, 1. Right? I have an array of 8. And then I have an array of 16. Let's pretend. What is merge sort doing? What's the first step it's doing?
Cuts it in half.
Going through all.
Cuts it in half, right?
Yeah.
So I go from 8 to 4. Right? 4 on each side. If I got 16, well, I just cut it in half one more time. And now I basically have this array, right? So instead of having to do 8 more operations, I just have to cut it in half one more time. And then now I'm good. And so that's where it's a logarithmic application, or it's a logarithmic equation in the sense of, and we'll do the math on Tuesday to show you, like, we'll get real into the weeds. If I have O of n, it is a linear time complexity, right? It depends on there's a total correlation of however many more values I have, there's more operations, right? It's a 1-to-1. If I've got 10 more values and it's an O of n, that means I have to do, worst case scenario, 10 more operations. When I'm logarithmic, I just have to do 1 or it is, if this was 4x, or I was getting to really high numbers, I'm really just adding in one more cut, right? So even if it's 8 to the 5th, right? Instead, I'm just doing 2 or 3 more operations compared to whatever that is, a huge number, right? So that's why recursion is going to come in handy, is because when we're doing things like sort, it's going to make it much, much easier. And you can see actually just adding in one more operation that gets me to where I was is going to be wildly impactful compared to 2xing or 4xing the amount of operations I have. Or maybe I would have 2 because I would cut into 8 and then have to cut the 8s into 4. But even then, it's so minuscule. Logarithmic in is much, much better than O of n. So that's why we would use recursion. Now, let's pretend that we've got a challenge where I want to get the length of a array, or I want to see how many values, how many values are in a array. And maybe the array is not a very easy array. What I mean is let's say let x equal this, where it's an array with arrays inside of it. Now, how would I do this with a for loop? Right? I might go through and iterate and check, well, are you an array? Okay, no, then maybe I have a counter, and then are you an array? Yes, well, then I do another for loop because I now have to do a for loop for that to get every single value here and then add that to my counter. And then I come here and I do another for loop, and you can see that that's not very that's not very great, right? Because now I've got multiple for loops within a for loop, and then it gets really challenging. Now with recursion, we can do it pretty simply. Again, I'm just wanting to see how many values are in my array, right? In the total array, I want how many individual values are there. Well, what I can do is let's create a function that basically has that. So we say function. We're going to call this recursive array. Oops. That takes in an array. Cool. Now, we want to keep track of how many values are in each one of them. So we're going to need some value called counter. That's going to be equal to 0, right? We're going to start it at 0. It could be empty, right? Now we still need to iterate through here, but I still need to do some iteration. And so what I can do is I say for let I equal 0, because we want to start there, right? I is less than r dot length. Dontrell, do you mind going on mute for me? I plus plus. Cool. Now there is a cool built-in checker that we can do, right? Because we're going to say, all right, are you an array? If not, cool, we're just going to add to the counter. Right? If you're not an array, we'll just add that number to the counter. We'll just increase it. But if you are, well, I need to do something differently. So what we can do is we can say if, and this is in the array property. So array.isArray. And this is going to give me a true or false, right? So it's going to say, yes, it is an array, or it's not an array. And so what I'm checking to see is, remember, if we have this here, this array here, this is position 0, this is position 1, this is position 2, 3, and 4, right? Index position. Now within that, they have their own index position, but from the outer sort of onion phase, we have 0, 1, 2, 3, 4 as my index positions. So this is saying, hey, are you an array at whatever, not 1, sorry, this is meant to be I. Are you an array? This is going to give me truthy falsy. It's going to give me true or not. And if it is, well, then I want to counter plus equals. I want to add to my counter, but what do I want to do? Like I want to do the same thing, right? I want to iterate through, so I could just say recursive array of I. So now I don't have to handle all of the different for loops within that. I just am calling the same function. That is if it is its own array, right? Or if it is an array. If it's not, well, then what do I want to do? I just want to increase my counter. And then at the end, we just simply, once this is all done running, let's return. So if it is an array, it's going to run this function again, which is then going to iterate through. And it's going to check, well, do I have an array within this array? Like, let's pretend that this was an array here, right? It's going to catch that versus we're going to have to build out multiple levels of for loops. Recursion does that for us, right? And so now if I were to console log this, then we should get, so if I were to console.log recursive array of X, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values in this. I'm just gonna make sure I don't do this, but I run this. I get a broken code. What did we do wrong here?
Can we say console counter instead of return?
Oh. I don't know why it was doing that. It's 9. It gives us 9. I don't know why it didn't. See how it had 9 here and then it has 9 here again? I don't know what. I was working on something earlier, so maybe that's what it was. But yeah, so it's giving us 9. If I were to clear this out. And I were to run this again, we'll get 9. Yeah,
Would it
so we get
be
9.
would it be harder like if we sort this array with the recursion?
I'm sorry.
Sort this X, would that be hard using recursion?
It's not hard. It's doable. It makes it challenging. Because now we're sorting, right? Like if we were to sort this, remember it treats these as different individual, there's what, 4 that we said? So there's 5 values. So it's gonna, if we did, you would use like math.floor typically. So you're gonna take like this value and this. So then this is easy, right? Because then it's just gonna split this and we just have 1, and then we have 2, and then we would compare those and put them in order. But here's where it would be challenging because then we would have 3, 6. So you couldn't necessarily sort. You'd have to check and say, well, is this an array? And if so, then go through it and then run sort. This is where recursion would be really great. Same thing here. So it splits those, and then this would be by itself. It's 4. So what it does is it makes every single one individual. And then once it's done, we just start comparing, and then you can put them all together. So not impossible, not an easy task either.
So we don't need a double for loop or anything, right?
Mm-mm. Nope,
Okay.
not with recursion. Now, if this was a what we call flat array, meaning that you know, that there was no nested for loops or anything like that, that would be really the dream. But if that was the case, then it's just O of n, right? Because with sorting, it is where we get in a log of n, and that's where recursion really shines. For this, it's just O of n. But notice, remember when we had we have multiple, it can be a you know, O of n squared, or something of that nature, which is much, much worse.
Thank you.
Yeah, of course. What's nice about this is instead of us having to iterate multiple times and have an O of n squared, what this allows us to do is still just iterate through each one of them one time, which gives me still of O of n versus O of n squared. That's the big draw here. Cool. We'll continue working with recursion. We'll do some sorting on Tuesday, and kind of working through that because it's something that is important. Is it like you should know recursion for sure? You definitely should know recursion. And it can be helpful for searching, like depth first search, breadth first search. So we'll keep looking at this on Tuesday. Sorry, we didn't get a ton of time. But are there any questions on recursion before we end class for tonight?
Reminds me of Inception.
Yeah, exactly. It's like a picture within a picture. And that's why I did this right here, where you have recursion within recursion, within recursion, within recursion, within recursion. So yes, very Inception-y for sure.
And you don't get an error message because you return the statement yourself, as opposed to circular importing type stuff.
Yeah, so there shouldn't be any circular imports. It's when we are dealing with something like this, or if we have a while loop, we need some sort of condition, especially here, we're not returning anything. But we need some sort of, until we are done here, but we need some sort of return or end condition, or else, this is just gonna go through the array length. When we're doing something like this, you must have a return, else it's gonna be infinite. And then you'll get Stack Overflow.
Perfect.
Yeah.
Is there something similar in Python, like recursion?
Recursion just you can do it in any language. So it's not just a JavaScript thing. The array is array, that's a JavaScript thing. But everything we're teaching you, whether it's merge sort, Java, or merge sort, recursion, singly linked list, you can do that with any language. It's not just, these are not, I want to make that very clear. These are not JavaScript things. They are just fundamental things you can do in most any language.
Oh, okay. I thought like there is some generic something you call a function in itself. Maybe I forgot something similar in Python.
Yeah, Python use self in the same way that you would use this. But no, this is, again, any of these data structures, you could do them in any language. So if you were to have this question, typically your job, your recruiter, whoever you're interviewing with, will say you can pick any language, Java, C#, Python, JavaScript, Ruby, any of these object-oriented programming languages, you can just use those to solve this.
Okay, thank you.
Yeah, of course. Any other
It's
questions?
basically just calling when you a function calling itself, right?
Exactly. Recursion is a function calling itself.
Cool.
It's the biggest takeaway here. We'll keep talking about it.
All right, cool. Thanks, Will.
Yeah, of course. All right, friends, we will see you next week. Happy last week. Can't believe it. Take care, everybody.
Thank you.
Bye-bye.